So this is another question on convolution. Uh, Similar steps, change all the t to tau and t to minus tau here for the h of tau. So I can just draw x of tau from 1 to 3, and this is e raised to the power minus e raised to the power minus t minus 1 shifted here. So this will be e raised to the power tau minus 1, and h of minus tau will be starting from minus 2 to minus 3, and the reference is minus 2. All the shifts towards this is plus, and all the shifts toward left side is minus. Now the case 1, we don't need to shift it more this way because we are already outside. So it will be, but we need to shift it further this way in order to have the last point of no overlap. So case 1, I will have the last no overlap, which will be x of t like this, and h of t, which will be, let me use green to draw that. So this will be from, because this is 1 second wide, so this will be just from 0 to 1, and this is my shift is from the reference. This shift is plus 3. So all the times for which we have t is less than or equal to 3, I have no overlap, and my convolution integral will be y of t equal to minus infinity plus infinity h of t minus tau x of tau d tau. That will be equal to 0. Case 2, when case 2, when this pulse moves partially inside. So I have my x of from 1 to 3, and the h of t minus tau is partially inside. So h of t minus tau is partially inside, and I can draw the end of this case, end of case, in which this is fully inside. So this is 1 and 2 and 3, because the width is 1. So this, and this is the time of this when it is fully inside is 4. So this is t equal to 4. So my case 2 will start from 3, and it will go all the way to 4, and this is my x point, this is my, again, my reference. So this is my plus t because it is right of the reference. So I can write x plus 2 equal to t, and x equal to t minus 2. So now my integral will be y of t equal to 1 to x, and x is t minus 2, and it will be e raised to the power minus tau minus 1 d tau. So this will be minus e raised to the power minus tau minus 1 from 1 to t minus 2, and that will be equal to, I can put 1 first, so 1 minus 1 0, so it will be 1 minus e raised to the power t minus 2 minus 1, so t minus 3. So now we will, the next case will be case 3, which will be greater than 4, but it will be less than the last case, which is when it is, so this case is when h of t minus 2 is fully inside. But end of this case will be when my pulse is just at the edge. So this is 3 and this is 2 because the width is 1. So, and this is my minus 2 reference. So this point is 5 shift, t equal to 5. So this goes from 4 to 5, and the case will look like this. My pulse is h of t minus 2 is fully inside. This is 1, this is 3, this is x, and this is x minus 1. Again, my reference is minus 2, so this shift is t. So x plus 2 equal to t, and x equal to t minus 2. So it will go from t minus 3 to t minus 2. So y of t will be just minus e raised to minus tau minus 1 d tau from t minus 3 to t minus 2, and I can just put that limit negative sign t minus 3 to t minus 2, and it will be I will put this first, e raised to minus t minus 4 minus e raised to minus t minus 3. Now check is I can check at t equal to 3, and I should get the same equation. So check t equal to 3 from case 2. It is y of t is 1 minus t minus 3, so 1 minus 3 minus 3 1, so 3 minus 3, sorry, at t equal to 4, check will be at t equal to 4 because that is the common time in these two cases. So 1 minus e raised to the power t minus 3, so 4 minus 3 minus 1, and from the case 3 equation it will be y of 4 will be 4 minus 4 1, and 4 minus 3 minus 1. So this is okay. Now I move outside the so it will be partially outside. That will be my case number 4, and that will be this case. This is 1 2 3, this is tau axis, and my h of t minus tau is now outside, so this is my x and this is x minus 1. So this is my overlap, this is my overlap here, this is my overlap here. Now end of this case is again when I am totally outside. This is the end of this case, right, when I'm totally outside. And this is, what is this? This is 3, so this is 4, so this is minus 2, and my t here is 4 plus 2 6, so this is t equal to 6. So my limits of this case will be greater than 5 and less than 6. and my integral will be y of t equal to x. Here is again, this is minus 2, so x plus 2 equal to t, so t equal to x equal to t minus 2. So it will be from t minus 3 to 3. D tau, and that will be e raised to the power tau minus 1 from t minus 3 to 3, and I put this first, so it will be e raised to the power minus t minus 4 minus 3 minus 1 e raised to the power minus 3 minus 1, so minus 2. Again, I can check, you can do it yourself. The check will be at t equal to 5, and case 3 and 4 should be same. So now the last case is when we are completely out of, so that is case 5. So that will be t is greater than or equal to 6, and then it will be no overlap, so y of t will be equal to 0. So now I have all these equations, and I can just draw it. You can draw it yourself. I will just write down the summary. So I will just delete this part and write down the summary here. So y of t equal to 0 for t is less than equal to 3, and y of t equal to 1 minus e raised to the minus t minus 3 for t between 3 and 4, and y of t equal to e raised to the power minus t minus 4 minus e raised to the minus t minus 3 between 4 and 5, and y of t equal to e raised to the power minus t minus 4 minus e raised to the minus 2 for t between 5 and 6, and y of t equal to 0 between, so t is greater than 6. And the next step is to draw this function. So I have 3 and then 4 and then 5 and then 6. So it will be 0 until 3, and then it increases until 4. So at 4 it will be 1 minus e raised to the minus 1, which is 0.632, and then this will come down, and then it will come down further like this. You can check it, and after this it will be just equal to 0. So you can check all these points for the amplitudes. This is 0.632.